Let's start then. And let's start by looking at what you asked for in the forms. Well, you asked for more examples. Hello, Helen, if you're watching. You asked for more examples. I don't know. Several people actually put more examples. I don't know what exactly you want, but in my lectures, we basically only do examples. So it can't be that. But well, Philip has read it. So he will give you. And in today's lecture, I think he's doing an example on a dynamic programming application. Should have the MATLAB code as well, and you should have a video. I don't know. Okay, so videos, in fact, is the second point. So this is a complicated thing. So I don't really think videos are any good. So, I mean, okay. So I'm doing this as an experiment. Nobody ever watches it. Well, some people watch it, but very few people. So maybe you'll watch the lectures before the exams. I don't know.
Exactly that.
But
Killian was perfect with that sort of stuff.
There's a kind of a risk of a sort of a superficial learning, I would say.
Is this to say that basically because you're now doing the videos, that why should the students even bother coming in?
No. Well, yes, but there's more to it. So we were asked, I don't know, I shouldn't be broadcasting it probably, but for example, when you get videos of past exam questions solved, okay, so what are you learning overall in university? Are you only learning to solve questions that you've seen a video of solved for you? Or what's the skill that you're taking, to your future life? That's my question. That's my concern. If everything that you need to do to pass and get good marks is solve a problem that you've already seen solved with slightly different numbers, then what are you actually getting out of your university degree? But well, that's just me. Yeah, so someone asked for Philip's lectures to be recorded as well. And I mean, in some sense, what I'm doing is, it's not absolutely trivial. I have to bring the computer, set it all up. I've bought a camera that only works with a Mac and doesn't work with Windows. And I could do it with that built-in camera there, but this one seems to give a better picture. But I don't know. So it's not absolutely trivial to do. And MMU has a plan to lecture capture everything from some point in the future. So it doesn't really, it's kind of, we don't get any support for it. So whatever I set up, whatever Killian has been doing, whatever other people do in this area is, yeah, it's just whatever we do. So I don't think Philip is going to start lecture capturing lectures, but he's providing plenty of short videos, which hopefully should replace the lectures, because they seem to be even better, because it's a short thing. You can watch it. You know exactly what you're watching. You don't have to look through a whole hour of a video to find what you're interested in. And that's the answer. The answer is there's probably not going to be videos of the whole lectures. What there is going to be, and what there is already, is short videos that explain the key concepts and also how to do the problems that you have to solve in your coursework, and how to do the problems you have to solve in your exam. that's the response. Any comments on that at all? Okay. Other people ask for more revision, old exams and mock exams and things like that. So there's always been two past papers in the library on the Moodle on the right. I mentioned that. There's a library section with the reading materials, reading list. So in there are past exam papers, and I've put some answers and some videos now from last year. Well, the videos are from last year, so they were for revision for last year's exam. So these are basically 2 papers with exams from not the latest one, but 2 before that. Does that make sense?
Yeah.
So that's there if you're interested. We'll do the revision then sometime in April, around Easter time. But if you want, you can start doing it now. You get the weekly exercises, so someone likes them, at least one wrote that they're good. I know Helen has told me before that they're good for revision in the end. Keep doing them. Someone asked for deadlines for our assessment. So everything is on Moodle. In fact, when you go there, I also send a reminder, if you remember, about the multiple choice questions test. And there are 2 deadlines. One is for term 1 assignments. There are 6 of them. And that's the 12th of January, the first Friday in January. Well, it's not the first Friday in January, but the Friday, first teaching week Friday. And then there's the remaining 4, that is sometime in March, and that's also a Moodle. So, and I'll remind you closer to the date. But, first 6 assignments, just after Christmas. And then after, I think there are 2 weeks of teaching after the last assignment is due. And so in general, we tend to use the labs for revision of past exam papers as well. And some people complained about last year's exam being faulty.
Faulty? No, not having to spot a question doesn't have to warn. Helps.
So yeah, so we'll make sure that that doesn't happen. I'll check them all personally before we go to the exam.
But yours were fine last year.
That's my response. Any more? Is that?
That's like this, or is it? No difference.
They turn them
Nothing
off.
happened,
Yeah.
right? So,
I was going to say, yeah, it's the double tap you have to do.
Is that what?
Yeah, that's fine.
Yeah, can you? Well, it's just too little light when you're taking notes, or is it enough?
that's fine.
Yeah.
I can't see the board anyway because the projector's in the way.
I didn't say yes, so cheaper. Do you want more light? No? So let's keep it like this. And it's also magic because it's like 3D glowing in the video. Anyway, it's like black, not like black, you know what I mean. Okay, enough of that. What's next? Okay, next is I wanted to check the homework question, and then this happened.
Projector's posted again. At least it's still on. It's not flickering on.
You could flip it over, yeah.
But then I can't write the answer. Okay, carefully read sections. I won't carefully read them now, but and I wanted to write the answer, but I can't write upside down really. Oh, I found something. Thank you. So I'll put last year's solution, and it's fairly simple, so you can check if you've done it. I hope it's correct. So it's 600 is the demand, that's the D. £25 is the cost of placing an order, that's the K. The cost of an item is C, but it doesn't really matter because it doesn't enter the formula anywhere. And stock holding cost is 5 pence, so that's the K. when you put it into the formula, you get 775. I think it's approximately 775, so it should be approximately equal. Which tells you that every time you place an order, you should order exactly, well, you should order 775 items. Doesn't say what they are, like that. And because you need 600 per week, and every time you're ordering, you order 775. That means that if you divide this by 600, you get 1.3, which is 1.3 weeks between any two orders, consecutive orders. Okay, that's the answer. I have some leftover chocolate, so we've done it. If you've done it, you take one. If not, pass it on. Just pass it back. I'll be watching carefully. Mistake. Have you solved it? Yeah. So you get a mark and you get a Swiss chocolate. Well, you don't have to take it if you don't like chocolate. Oh, plenty of chocolate left for me. It's good that I brought it at a time when people are starting to be oblivious to homework, so I can look like I'm a nice guy for a long time. Right, so what did we do last week?
Speakers and TV.
Yes, but we didn't quite finish the example because I wrote the theorem in a rush. And
We've got to decentralization.
What's this? Switch this off, and then I can't see. Where are my notes? Give me my notes back. There we go. Right, so what we had was this theorem. That's where we finished, and we didn't. I didn't say why. It's this, but it's a revision from first year decision maps. So let's quickly do the proof of this theorem again. Okay, so let's see what we have. The goal is to minimize the average cost per month or per period. Average total cost. And the total cost per month is, okay, so C. And what does it consist of? Okay, we should, oh right. We should put some notation. So we know what K, D, H, and C are. They're the parameters. K is the cost of placing an order. D is the demand per month. H is the stock rolling cost per unit per month. And C is the cost per each item. Q is going to be the size of each order. And T is the length or the time between two orders. 2 consecutive orders, and we know that if the demand is D, so that was, and the amount ordered is Q. That was the same as we saw in the example. 775 divided by 600 was the length of time between 2 orders. So T is Q divided by D. So the cost is placing orders. Okay, we get K every time we place an order, and we're placing 1/T orders every month. Yeah, so that cost is K/T. Does that make sense? The cost of actually buying the items or producing the items, whatever it was, is, well, C is each item, and every month we need D of them. And that's this. Well, that's going to go away anyway. And then the stock holding cost is, right, so I didn't say what we're doing, but well, I'll probably say what we're doing. So we want the order to arrive exactly when we run out. Because if we get some, what is called the safety stock, so some non-zero stock for all of the time, that would mean we're just increasing the cost, stock holding cost, because we would have, on average, more in inventory than if we don't keep any safety stock. And because of our assumptions that everything arrives exactly when needed, we don't need any safety stock. We only need safety stock if there's some randomness in the demand or randomness in the supply. But we're assuming that the demand is, some revision from last week, demand is constant and known, and nothing happens with it, no random fluctuations. And we're assuming that the lead time, so the time between we place an order and when it arrives, is constant. So we can assume that everything arrives exactly when we need it. So that means we want everything to arrive exactly when we have 0. Okay? It's like this graph. So what's the cost, stock holding cost? Well, it's per month. It's H per unit. Okay, and on average, we have Q/2 units, because at the beginning we have Q, at the end we have 0, and it just keeps decreasing at a constant rate. So we have Q/2 on average, so we get H times Q/2 cost per month in an average month. So it's different in different months because the ordering point comes at a different day in the month, but this is what it does. Okay? You're puzzled.
Just that you've got C twice. That C is one of our CD. So.
What? Oh, because that's a capital C.
Oh, that's big C.
Yeah. I'll make it bigger. Okay, C is the total cost per month. Okay, good to clarify. It's even worse in Callum's train formulation. He just does I and J look completely the same, little or big. Okay, so that's this. Now, minimum cost. So how do we get? So this cost, I should say, what does it depend? Well, it depends on all the parameters, but what we're trying to find is the best value of Q, where the cost is minimized. You can think of it as a function of Q. So what I should really be doing there, and it's good that Helen's not here, because she would kill me for it. It's a C as a function of Q. Now, if you have a function like this and you want to find the minimum, what do you do from year 1? What? What? No. What do you do?
Alan said.
No.
Yeah, what did you
But it
say?
stays quiet.
How am I going to say?
Did you say differentiate?
No.
Why not?
It.
Do you agree? Do you agree? Yeah, Neil agrees, so it must be right. It is, in fact. So yeah, so you do the derivative of this by q, because q is the variable. The rest is just constants. Okay, so I'm messing up here. Because, oh dear, this is what today. I want this t here to be expressed as q over d. Right, so what I get is, this is k times d over q. That's k over t. Substitute t expressed in terms of q. You get plus, and the rest remains the same, so plus cd plus qh divided by 2. Now we can actually differentiate. So what's the derivative of kd over q? Minus kd over q squared. What's the derivative of cd? Yes. So it's 0. And the derivative of q times h over 2. So you want this derivative. Okay, now we've differentiated. What do you do with it? Yeah. Find q for which this is 0. Well, this is something like kd over q squared. It's supposed to be h over 2. Okay. That is 0. And if that is true, then you get q squared equals 2kd divided by h. In which case you get q is the square root of 2kd divided by h. It could also be negative, but negative solution is not really what we want. But quite right, we can't have a negative amount of ordering. We can actually have negative inventory, we'll see in a minute, but we can't have a negative q. Okay, so this is a candidate to be a minimum. And if you do the second derivative, which I'm not going to do, you get 2kd divided by q. Something like this. This disappears, this is going to be q, and this plus is going to be plus 2. Which I'm not doing, but from the second derivative, so from, I can ask you to do it, d squared qt, oh, what am I doing? D second of c by q is greater than 0 in this point. It's a minimum. Actually, if you took the negative square root here, you get the maximum. Yeah, so if you start ordering negative amounts of stuff, you're maxing out the cost. Probably not the point. Anyway, this is the end of the proof of that formula. This is the theorem, so that's it. And now we had the example, didn't we? How many speakers to produce? So that's in the video, and I said shut up to the computer because it's come up with a reminder that we're meeting for the project. Apply to the speakers example. Just to finish that off, what we get was okay. You tell me. 2. What was D?
12,000. D, sorry, 8,000.
Oh, no.
12,000 times 8,000.
What's 8,000?
8,000 was the demand rate.
Oh, no, it's 12,000. It's an expensive factory. I don't know. Did we do it last week? No, we didn't. It's not pence. This is the. Well, you could do, but you're producing a batch of speakers, so you're not producing a fifth of a speaker. Perhaps, yeah. And what's the time between 2 orders? So this is the time between 2 consecutive orders, 2 consecutive batches. Batch runs. Okay, so that's the optimal production policy. We run batch every 3.2 months and 5,300 bits. That finishes the example. Any questions? Answers? Good comments and silly. Remember, it's only noise. Okay. Let's move on to the next. Next, isn't that thing? So system. It starts with that being upside down. Then it makes nasty noise when you touch it. Oh, that's the second slide. That's the first one. Right. So okay. So what do we have now compared to what we had last week? Is that we're saying it's sometimes okay to run out of stuff. It comes with a cost. But perhaps that cost is not as large as keeping huge amounts of things in inventory. Okay. So that's what it's like. I mean, you work at Tesco, one of you.
I would Morrison's.
Morrison's even better. So you know that it's probably very costly to keep an stock of everything so that you make sure that you absolutely never run out.
Yeah.
And that's why you allow sometimes to run out, even though people get upset.
Very pissy.
But that's still worth it, they reckon. And better than keeping a huge amount of safety stock, making sure that you never run out.
Or in our case, we always keep safety stock.
Does that-
what they do?
Is that roughly correct?
Well, we have this thing, this policy that, you know, it will sell. That's always been their policy. It will sell, no matter what. Even
Yeah.
like having those, what they call disposable barbecue things in the dead of winter. We've still got some wrapped up in like plastic in the sky, as it's called. We have like rackings on a pallet. We put it in the sky, and they're up there still. They've been there.
Yeah, but
since
you
summer.
still sometimes run out of milk.
We don't often, but yeah, it does happen. Particular types of milk, but that's because there's only a daily batch of that, and it's only finite. Whereas the barbecue things do not sell. We'll keep them, and we'll sell them. At
Okay, yeah, okay. So I admit it's a bit more complicated in practice, but let's have a look at a simple example so we can do some maths on it. So what happens is there are two models that actually, in the end result, are the same. And one of them is that you have delayed revenue, which means that you're assuming. So that's usually, this is if you're a big wholesale supplier usually, and you have your customers are small shops perhaps. People sell it. And they just wait for, you say, oh, sorry, we don't have it. And they say, okay, so when you have it, supply it. So that's when you give them a discount perhaps. So that's like, so this is when you're assuming backlogging. Yeah, they come and they ask for it, you don't have it, you just write the order down.
Yeah.
And once you have it again, you send it out. And perhaps you give them some discounts. Okay, so that's the cost of this, and the cost of lost revenue is that's more appropriate to the supermarket situation, is that there is no backlogging, so customer goes away.
They do, but it's never as nice as what you said. It was, all right, okay.
We had a lot of lost revenue at the weekend because our ferry went off, so we had to go full evacuation. That was not fun.
Okay, that's not part of the model.
But customers did go away.
Yeah, I know. Another part of the cost is that if people come very often and there's no milk, they're going to say, okay, next time I'm going to Waitrose because they have, well, actually Waitrose don't have milk very often.
Do you know what? That's never been the case, but it might be soon.
Okay, so so there might be some loss of future sales. The customer decides, I'm never going back to Morrison's, or I'm never going back to
that per week.
Back in the day.
Yeah, exactly, because they live around the corner.
You have some costs because you have to, if you're doing backlogging, for example, you can have a cost with actually taking the notes and then fulfilling the orders and so on. Yeah, some costs. If you're doing it like in the speakers example, you have to stop your production line because you don't have speakers. So that's a cost of not running out of the speakers when you're doing the TV sets. So that kind of thing. So you just simplify all these costs, and then you assume that it's people. Just you don't really. I mean, you let some analyst. Well, you do it, but you do it separately, and then for this one, you say that the cost of being one speaker short per 1 month going to be. Okay. And what else did I want to say? So the assumption that we had before, we had assumption 3. What was assumption 3?
Take the back off now. No, not on that one. Literally, it's just on that one. Oh, plant shortages are not allowed.
So this is changed. Plant shortages are now allowed.
Okay.
And they cost P per unit short per unit of time. So I'll write per month. Of course, if your unit of time is year or week or whatever, then it changes to year or week or other unit of time. Okay, and the other two assumptions, they just remain the same. So what were the other two assumptions?
Demand is constant.
Oh, that was it, yeah.
So we're still assuming that everything arrives exactly when we need it. And we still think that the demand is just, so things are disappearing at a constant rate, so you basically get a stream. Now, what do I want? I want a new page.
Oh, give me a sec.
You can see 1 and 2 are unchanged.
Oh yeah, I know.
We're still here.
Yeah, sorry. Oh,
Just rewind the video. Then.
no. Start time. Or other of time. No. Yeah. Okay.
So we're running out of time again. This is insane.
That was literally 12 seconds.
No, it's not because of you. It's because of I don't know why. What's the theorem? Okay, I won't write the theorem. I'll draw a picture. Okay, so when you think of this is time. This is amount in inventory. Okay, so what we have now is, well, we have a certain amount, okay? And then as time goes by, keeps decreasing. And now we're not planning for the new batch to arrive exactly at this moment when we hit 0, but we might allow this to go negative. So that's a model, of course, because it doesn't really go negative, but these are all the, either we're doing backlogging, so this amount is the amount that is backlogged, or we're not doing backlogging, and then the people who come in this time, that's the lost sales. In any case, we're going to end up at some point here, and then the batch arrives, and then the same thing happens again. So we go down, 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 down to negative, and then they're supposed to be exactly identical. I'm not sure whether I'm managing. They're roughly identical. minus 1.1. So think of them as identical, okay? And that this is how it goes. Yeah. So now what we had before was, we said that this amount here, that's the Q. That's the size of the order. Okay, that's the same as before. Now, what we have here, I'll call it S, and that's the total lost sales or backlogged sales in one cycle. So every time. Imagine this is going negative, but that's just a graph. In fact, our inventory is 0. But what we're having here is we're getting the cost P per unit per time. This graph here, does it make sense? Oh. All right. So again, we want to minimize the average cost month, or unit of time. I'll call it capital C. But now it depends on both Q and S, doesn't it? Before we decided that S should be 0, so we only had Q as the decision variable. Now what we're looking at is the size of the order and also the amount of backlogging that happens every cycle. So what's the cost? Well, following the formula that we had before is a good start. So what did we have before? Okay, so this is, again, I should write, this is the average cost per month is.
K/2.
So what was it? DK over Q?
Yeah.
Was the first one. That was the cost of ordering. So in terms of Q. So that's the same. It doesn't change, does it? Because we still order Q every time. The time between two orders is still Q divided by D.
Yeah.
T as well.
Yeah.
I shouldn't put the capital T here because it's not capital T, it's time. Oh, no, what have I done? Removed it a bit too much. So this is the time axis. Okay, T is mark T. T is, what is T? T is this length. But anyway, so this remains the same. What was next? Next we had CD of purchasing the items. Okay. Maybe this isn't quite the same because this is when we do backlogging. We have lost sales and we're purchasing less. But well, okay. So let's say we're doing backlogging, and then we have this, and then what else do we have? We had the stock holding cost.
K times Q over QH over 2.
Oh, what have I done? I apologize. I've done something differently. I don't want this amount to be S. Sorry. I want this amount to be Q minus S. I apologize. I got carried away. So S is the top bit. S is what we actually have when the order arrives. Sorry about that. It's just a notation. I could have carried on like this, but my notes, I would have made a mess of it. So it's better for everyone. So what's next? Okay, so oh, this is getting harder. We're running out of time. This is when you start improvising. What happens? You get completely. I'll write the formula and I'll explain it next time. So this is S squared times H divided by 2Q. And the last, there's a new cost, which is Q minus S squared divided by 2Q, and this is times P. So this is the shortage cost.
It's the same as the first equation, but it's zero. Q minus S is 0. From the first equation, it's the same, just when Q minus S is 0.
Yes, that's right. Q minus S is 0,
which
is what we had before, and this goes away.
that goes away, and then that one just
So
goes what it was
P
earlier,
is-
it goes to Q squared.
Yes. So you trust me now.
Yeah.
But I'll explain why this is. So now you can't solve the homework, can you? Because I've not given you. Oh well, then just don't solve the homework. Yeah, well, unfortunately, being a bit slower than other years, so I'm probably getting bored by it. But yeah, any questions? So this is the cost. I'll explain how you get these two. But as Colin has rightly observed, it's the same if Q is equal to S, which was the previous model. So you get the previous model. You get it basically because you still have you get it, and then from this, again, we'll have to take partial derivatives. In this case, we have two variables, set them both to 0, solve it, and that's it. See you Friday.